Thank you for supporting CMA Math Academy. If you're watching on YouTube, don't forget to like, comment, and subscribe for more great CMA math content. What's up, guys? It's Mr. Grady. Today we're going to be doing some Cornell notes like we always do with our vocabulary. Let's get started. Alright, so what are we learning today? Why are we learning this? And how will we know if we successfully learned everything we need to learn? So what are we learning is, as I said, Cornell notes, key vocabulary terms associated with the number system. Why are we learning this? We're beginning our new unit over the number system, and we need to become familiar with the vocabulary we're going to be using during this section. So Mr. Schrag's going to have the next video kind of teaching us through our first lesson, but in order to get into those lessons, we're going to need to understand the vocabulary terms, because believe it or not, even though we think of numbers like 1 and 2 and -5 as just numbers, they have labels or different names that go with them. We have to know those labels and different names. So how will I know if I've successfully learned everything I need to learn? So when you're given a vocabulary term, like we always do, you're going to create a question, and then you're going to use that question at the end to write your summary. And if you can do all that, you have successfully learned everything you need to learn for today. Alright, so let's go ahead and get started. Remember, as we do these, we're going to get to a word, you're going to say the word, you're going to write everything about the word, and then after that, you'll go ahead and do the question. So save the question for last. There's some other things we're going to do just a smidge differently than before, but remember, question is the last thing we do. Alright, here we go. So first of all, you're going to fill in your unit title box, which is expanding the number system, and then your unit objectives and goals. So I'm going to give you just a second to go ahead and do that. Alright, so now that you've had a chance to write this down, let's go ahead and read through our unit objectives and goals. So as we always do, you guys are going to say the words that you filled in. So under unit objectives and goals, you guys had the first word. So on 3, you're going to start us off with the first word, and then we'll just read it from there. Okay, so in the first bullet, on 3. 1, 2, 3. And analyze. And among types of. Alright, let's go down to the next objective or goal. Number 2, determine locations of numbers on a. So approximate, maybe we've heard that word before. Irrational, that's a word we might not have heard. We've not talked about it with numbers, so we'll get to that here in just a minute, what irrational numbers actually look like. We're going to put those on a number line. Now this last one's kind of weird, so we're going to practice saying this word before we actually say it. So I want everyone to repeat after me. Say Pythagorean. One more time. Say Pythagorean. Say theorem. Okay, let's put it together. Pythagorean theorem. Alright, so when we get to those two words, you guys are going to say them. Ready? Use the to determine unknown side lengths in a right triangle. Alright, so let's move on and let's get started. So our first word today is real numbers. Everybody say real numbers. So I'm going to give you about 15 seconds here before we start writing, and I want you to just discuss at your table or with your table partner what you think we're talking about when we say real numbers. So if you had to guess what the next slide's going to say, what are real numbers? What does it mean? What do you think? So about 15 seconds, ready, go. So now that you've had a chance to kind of see what we think it means, let's actually look at it. So when I go to the next slide here, you're probably a little confused because you're like, wait, human beings, this has nothing to do with math. But here's the deal. So real numbers, which is our first word, is kind of the equivalent of human beings. Okay? So with human beings, we have this giant kind of title that all of us are human beings. And then underneath human beings, there's different subcategories. So we can separate human beings into boys and girls. We can separate human beings by their hair color, brown hair, blonde hair. We can separate human beings by their age, like young or old. So human beings is the big topic that we all are, and then from there we can split out into different subcategories that are all human beings. So again, boys are human beings, girls are human beings, brown-headed people are human beings, blonde-headed people are human beings, young and old people, we're all human beings. So human beings is like our giant topic that is the umbrella or the overall topic for these subcategories. Okay, so think of that as we're about to go into real numbers. So you didn't need to write that one down. Here's what we're writing down, real numbers. So I'm going to give you a second to write this, then we'll kind of go through everything. So I'm going to give you a second. I know there's a decent amount to write. Go ahead and write, and then we'll talk about it. Okay, so let's kind of break this down a little bit. So remember what we were saying about human beings. Human beings are the big category, or the topic that everybody falls under. Well, real numbers in this case is the big topic that all these other types of numbers fall under. So real numbers really just mean any of these types of numbers that we're about to learn about. Just like human beings can be boys and girls, real numbers can be whole numbers and integers. Just like human beings could have brown hair or blonde hair, young or old, real numbers can be rational or irrational. So let's look through each of these. So as usual, when I get to a part that's underlined, you guys help me out and read it. Okay, so we're under the box that says whole numbers. All right, so whole numbers are a number without a, or, so to be a whole number, can't have a fraction, can't have a decimal. Okay, let's go to integer. Everybody say integer. Okay, again, you guys got the underlined words. An integer is any number that is, or, and includes. So again, an integer has to be a whole number. We talked about that, and we'll get to examples here in a second. Can be positive or negative and include 0. Okay, let's go to the next one. Everybody say rational number. One more time, say rational number. So again, a rational number is any that can be written as a, so any number you can think of that can be written as a fraction, that's a rational number. Okay, let's go to irrational. Everybody say irrational. One more time, irrational. So an irrational number is a that neither or. So let's break this down a little bit. Again, a decimal, so it has to be a decimal, that neither terminates, so it can't terminate. So think of terminates as stops. So some decimals, a lot of decimals we look at, stop after a certain number, like 2500 stops after the 5. To be irrational, it can't stop, and it can't repeat. So think of a repeating decimal, like 3/10 repeating, 3333333, it repeats. To be irrational, it can't stop or repeat. So we'll talk about what this will look like. Okay? Okay, so now let's look at some examples of each type. So I'm going to give you a few seconds here to write down the examples, then we'll talk about this, then we'll write our question about real numbers. Okay, so take a second and write down our examples. Alright, so now that we've had a chance to write this down, let's go through and break down our examples for a second. So at the top left, one more time, we have whole numbers. Everybody say whole numbers. Remember, whole numbers can't have a decimal or a fraction. So each of our examples here, none of them have a decimal or a fraction to them. 23, -8, 12, and 9. They're just whole numbers. Let's go down to integer. Everybody say integer. Again, to be an integer, you have to be a whole number, so no decimals or fractions. You can be positive, like 25, or negative, like -9 or -2, or 0. So 0 is included. So 0 is an integer. One more time, everybody say integer. Alright, so here are the two that are a little more fun here. So rational numbers, remember a rational number is any number you can write as a fraction. So 5 is a rational number because I can write it as 5/1. I can write it as a fraction. 2500 I can write as a fraction even though it's a decimal as 25/100, and I could reduce it from there, but I just wanted you to see how it looks to start with. 0 is actually a number I can write as a fraction because I can have 0/4 or 0/10, 0 over something, so 0 is rational. And even repeating decimals, even though they're kind of crazy and long sometimes, I can write those as fractions, and we'll get to that in this unit, how you know if it's a repeating decimal, what it's like as a fraction. And let's look at irrational. So remember, an irrational fraction. So remember, an irrational number doesn't terminate or repeat. So we have this sign right here, and I want you to turn to your partner real fast and see if you can tell them what this sign means. Ready? Tell them. Okay, so hopefully you said this is the sign for pi. Now, not like the pie you eat. This is just pi, pi. And the decimal for pi is 3, and I'm about to say a word that we don't ever say, but just because it's impossible to say what this decimal is. So it's 3 point, I know I hate saying that word, 3.1415926, and it just keeps going on and 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 on forever. So remember, to be an irrational number, it can't terminate, so it has to go on and 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 on forever. and it can't repeat. So yes, there's a 1 and a 1, so the 1s are repeating, but it means the whole cycle has to repeat. So we don't see another section that says 1, 4 in here or 1, 5 in here. Nothing's going to repeat. So pi is irrational. The next number we look at is this 8, and it has a weird sign that kind of looks like long division, but it's actually not. We'll get to this here in a second, but I want to see if anybody can tell their partner here what this symbol means. Okay, ready, go. All right, so let's see how we did. This is actually a square root symbol. So everybody say square root. Okay, so we're going to get to that here in a minute, what square root means. So again, the square root of 8, if we type that into the calculator, is a decimal that goes on and on and on and on and on, doesn't terminate, and it doesn't repeat. So again, even though the 8s are occurring more than once, the actual pattern is not repeating, and it would go on forever. So hopefully you've noticed that in some instances, like the number 5, you can fit into more than one category. So 5 would fit under whole number, it would fit under integer, and it would fit under rational number. 0 would be a rational number and an integer. We talked about that. So as you can see, some of these numbers actually fit in multiple places. So going back to our example with humans, I know that there are humans that are boys, that have brown hair, that are young. So you can fit under multiple categories. Or a girl that has brown hair that's old. I can fit under different categories, and that's okay. So the next step we're going to do, as we always do, is write our question. Remember, our questions go in the left column. You can use your Costa's levels of questioning stems and verbs that I've provided on your desk, or you can look up at the screen if you need a verb to use to help you. But I'll give you about 30 seconds here to come up with a question. Remember, as we write our questions, we do not say, what are real numbers? Or what's the definition of real numbers? We need a better question than that. We've had practice with this, so hopefully that's no problem. Okay, I'm going to give you a second. Come up with a question. All right. So from here, we're going to read our question to our table partner. So 1s are going to start us off. 1s read your question, followed by 2s reading their questions. Okay, ready? Go. Now that you have read your question, let's go on to our next word. So our next word we're going to look at is called absolute value. Everybody say absolute value. One more time, say absolute value. Okay, like we did before, I want you to kind of estimate or assume or predict what you think absolute value is going to be about. So I'm going to give you a second to turn to your table partner. 15 seconds to discuss what you think absolute value is about. Ready? Go. All right, so I'm going to give you a second now to write down all of our information for absolute value and our example, and then we'll go through it. Go ahead and write it down. So let's go ahead and go through our information for absolute value. So one more time, help me out. Say absolute value. Again, absolute value. Okay, so let's look at the first bullet over to the left that you should have filled in the blanks. Again, you guys are telling me what you wrote in the blanks. Okay, ready? Here we go. So the first thing says a number is from on a. Okay, so that's the first thing. It's the distance a number is from 0 on a number line. Let's look at our second piece of information. It says the is always. Okay, so let's look at what that means. So over here, we have our absolute value symbols. These two bars represent absolute value. Now, when you draw this or you make this on your paper, make sure your bars are a lot bigger than your numbers. Otherwise, it might look like 181. But these are two big bars that say absolute value. So this is how we show absolute value. So again, it's the distance, our number, which is the absolute value of 8. So it's 8, is from 0. So we know that 8 is 1, 2, 3, 4, 5, 6, 7, 8 spaces away. So it's 8 is the absolute value. Same thing with the absolute value. Remember, these bars mean absolute value of negative 8. Negative 8 is still 1, 2, 3, 4, 5, 6, 7, 8 places away from 0 on the number line. So the absolute value is also 8. So again, the answer to absolute value is always positive. So you're going to repeat after me, always positive. So you keep the number, negative 8 stayed 8, keep that number 8, always positive. 8 is 8, always positive. Okay, so that's absolute value. Let's go ahead, and I'm going to give you a second to write down a question for absolute value. Remember, we don't want to just say what's absolute value. We're thinking of higher level questions. Go ahead and write it down. Okay, so go ahead and turn and share with your table partner, starting with partner number 2, and then 1s will read. Okay, very good. I'm hearing some great questions today. Let's go ahead to our next part, which is squares and cubes. Everybody say squares. Everybody say cubes. Turn to your shoulder partner, say squares and cubes. All right, so I'm going to switch it to the next one. And this one kind of has a little bit to write down, so I'm going to give you a little extra time to jot this stuff down, including the examples, and then we will discuss. Okay, so let's go through this. I know this was kind of a lot to write down, so we're going to kind of really go through this, make sure we understand everything that we did write down. So again, our words were squares and cubes. Everybody say squares and cubes. When I get to a word that is underlined, again, you guys help me out, everybody participating as we go through this. So our first bullet over to the left says, to a number means to the number by itself. Okay, let's go to the next one. To a number means to the number by itself. Okay, and then lastly, the of squared is and the of cubed is. Okay, so let's look at this. So to square a number, again, means to multiply by itself. So if I have 4 squared, so we've seen this symbol before. 4 squared just means 4 times 4, which is 16. So 4 squared is 16. Now we need to make sure we understand this is not 4 times 2. 4 times 2 is 8. This is 4 2 times, or 4 times 4, which is 16. Same thing with cubed. 4 to the third power is not 4 times 3. 4 times 3 is 12. 4 to the third power is 4 3 times. 4 times 4 times 4, which is 64. 4 times 4 is 16. 16 times 4 gives me 64. So again, we have this other word that says perfect. Everybody say perfect. So if you square a number or cube a number and it gives you a whole number answer, remember we talked about earlier, a whole number is no decimals or fractions, then that's called a perfect square, say perfect square, or a perfect cube, say perfect cube. So these are the ones we want to work with. These are a lot easier than if we square something and it's a decimal. So it's a perfect square or a perfect cubed. Now our last section that we wrote over to the left talked about square root and cube root. So we've talked a lot about inverse operations. So we know the inverse of addition is what? The inverse of multiplication is what? So we know those things. So the inverse of squaring is square rooting. Everybody say square root. The inverse of cube is cube root. Everybody say cube root. So again, this is really just the basic vocabulary. We will use these two items, but we'll do it a little bit later on. So we're not going to go too far in depth about what they would look like, just that we're familiar with these symbols mean square root and cube root. So again, the only difference is that for a cube root, you put this little 3 here. Otherwise, square root still looks the same as cube root. Again, cube root just has a 3. All right, so let's go on to our question part. So I'm going to give you a second to write questions over squares and cubes. We're going to share this with our partner. Again, no repeat questions. We got to be using our brains to come up with higher level questions. So no repeats and no easy ones. Okay, ready, go. All right, so let's go ahead and read our question to the person next to us, starting with partner number 1. Go ahead and start. Okay, so now that we're done asking our questions, let's look at our next word. So our next word and our last word is Pythagorean Theorem. So we saw this word up in our objectives. Everybody say it with me. Pythagorean, say Pythagorean. Say theorem. One more time, say Pythagorean. Say theorem. And then put it together, Pythagorean Theorem. Alright, so before we switch over to Pythagorean Theorem, I want you to kind of guess what you think it is, or maybe you've heard this word before, but I'm going to give you a second. I want you to discuss it with your table partner. What do you think this great big word means? Okay, ready? Go. Alright, so now that you've talked about what you think this word might mean, let's go ahead and let's actually look at what it is. So I'm going to give you a second as always. Go ahead and write this information down. Alright, so now that you've taken a second and written this down, let's kind of break up what this is talking about. So again, we have this weird word, Pythagorean Theorem. One more time, say Pythagorean Theorem. So Pythagorean Theorem is just this math concept that's made up or that comes from a person. It's named after this guy named Pythagoras. So think of it like if Mr. Schrag, who's super smart, came up with this theorem for math or came up with this equation or this formula and they named it the Schrag theorem. It's just like that. So Pythagorean theorem, just like if we had the Schrag theorem. So one of these days, your kids or your grandkids, they're going to open up their math book, they're going to learn about the Schrag theorem like we learned about the Pythagorean theorem. Okay, so let's talk about Pythagorean theorem. Again, as always, you guys have the underlined words as we read through this. So it says, the Pythagorean theorem is A, used to determine the of a side in A. Okay, and here's the formula. Now, instead of you guys reading it, the first time I'm going to read through it so you can hear what it is. So the formula is a squared plus b squared equals c squared. One more time. A squared plus b squared equals c squared. Turn to your partner and tell them the formula. Go. Okay, so now one time as a class, everybody, a squared plus b squared equals c squared. Ready, go. We've used different equations that have variables x and y. This is a formula. So what that means is that these letters, a, b, and c, they represent a value. And here's what I mean by that. So we have a squared plus b squared equals c squared. Well, on a right triangle, now remember, it has to be a right triangle. We wrote that down. A right triangle is one that has a 90-degree angle in the corner. Now, it doesn't always have to be sitting this direction. This is just the example I'm showing you. But it has to be a right triangle. In a right triangle, the two legs, everybody say legs, the two legs could be A or B. A or B. So I could have A on this leg and B on this leg, or switch it and have B on this leg and A on this leg. But the thing that's important is that the letter C is always, 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 everybody say always, is always what's called the hypotenuse. Another weird word. So everybody say hypotenuse. Hypotenuse. One more time, hypotenuse. Okay, so the hypotenuse is just a fancy word for this diagonal side. So C is always the diagonal side. Okay, so A or B could be interchangeable, but C has to always be the hypotenuse or the diagonal side. Okay, all right, so now that we've learned a little bit about Pythagoras theorem and we're going to know about the Schrag theorem eventually, let's write our question. All right, so now that you've had a chance to write down your question, we're going to share that with our partner, so go ahead and share it. Table partner number 2, you are going to go first. Ready, set, go. So now that we've finished asking our last question, let's move on to the most important part of our notes. So using complete sentences, these aren't bullets, okay, complete sentence like a paragraph, you're going to answer each of your questions like we always do that you created. To write your summary for today's notes, you should have one sentence for each question you have created. So once you think about this, go back and count how many questions you have. That's how many sentences. So you don't have to ask me or Mr. Schrag how long it has to be. Just count your questions. That's how many sentences your answer should be, at least. Okay. So I'm going to give you a second to do your summary. We're going to conclude by sharing our summaries to our table partner, and then we will be ready to go. We have learned what we need to learn for today.